All right, fifth graders, well, we're getting into chapter 14 in today's video, and lesson 1 here in chapter 14 has to deal with classifying triangles. And when we classify different types of triangles, we do it in 3 ways: by their angles and by their sides. Now, you all know what a triangle is. If I was just to put a basic triangle right here, you would understand that. A triangle has 3 sides: 1, 2, 3. And it also has 3 angles. And the angle is basically a measurement right there. It's an angle. Okay? And we have different types of angles. We have acute angles, okay, which are these smaller ones. They're acute. They kind of almost look like a less than or a greater than sign. Okay? They're not a perfect L. As you can see, the right angle is the perfect L, and a right angle is also corresponded with this little box. So when you see that symbol, that's a right angle. That's 90 degrees. And an obtuse angle kind of has the mouth opening up either way. Those are greater than 90 degrees. And then we actually also have straight angles, just for information purposes. And a straight angle is 180 degrees. Now, when it comes to classifying triangles by their angles, now a triangle has 3 sides, thus it has 3 angles. In any polygon, how many ever sides the figure has, that's also how many angles it has. It would be considered an acute triangle if all 3 of the angles were acute angles, which means they're less than 90 degrees. Okay, so if all the angles were like this, smaller than the perfect L, it would be an acute triangle. It is an obtuse triangle if just one angle is an obtuse angle or greater than 90 degrees. So if just one of the angles in the triangle is bigger than the perfect L, then it's considered an obtuse triangle. A right triangle has a 90-degree angle, just one. It would have one 90-degree angle, then it would be considered a right angle. Now, just for other information, if you add all 3 angles together in a triangle, it will equal 180 degrees. That'll be something that you'll need to know in your future math lives, not for what we're doing today, but just for informational purposes. When you have a triangle, the sum of all 3 angles added together will always equal 180 degrees. Every triangle in the world, that is true. You will also have equilateral, or sorry, not equilateral, equiangular triangles, in which all 3 angles measure the same. So you can kind of think, if the total is 180 degrees and they're all the same, you could do 180 divided by 3. 18 divided by 3 is 6. Add the 0. All 3 angles in an equiangular triangle are 60 degrees. So I suggest maybe you just take a screenshot of this and have that to refer to. You'll get this in your notes in class the day we do this lesson, but I would take a screenshot, write this down, and have this about classifying triangles by their angles. Acute with 3 acute angles, obtuse with one of the angles being an obtuse angle, which is greater than 90 degrees, or a right triangle where one of the angles is 90 degrees, a right angle signified by those boxes. And we also have equiangular, in which all 3 angles are the same. And we did the math to figure out that would be 60 degrees. All right, so you're going to want to have that somewhere where you can refer to it. We also can classify triangles by their sides. And we first of all have a scalene triangle, which involves all 3 sides being different lengths in a triangle, all 3 sides being a different length, which basically meaning we might have a side here, and then a side here. That would be a scalene triangle where all 3 sides measure differently. Okay? Now, equilateral triangle, all 3 sides are the same length. Now, you'll notice I put little different indicators there to show that these sides are all different. If 2 of them just have 1, or if 2 of them just have 2, that means that those 2 side lengths are congruent. Equilateral means all three sides are the same length. So if you get a triangle where all three sides are the same and it has the same indicator through all three lines, that would be an equilateral triangle because all three of those are the same length. We also have an isosceles triangle. An isosceles triangle has two congruent sides. Now technically, all equilateral triangles are also isosceles triangles because you have two congruent sides. Even though technically you have three, you have two congruent sides. Thus, this actually fits an isosceles triangle. But traditionally, when we think of an isosceles triangle, we think of something more like this, where two of them are the same and one of them is either longer or shorter, whatever the case may be for that triangle. And that's an isosceles triangle. Now, what are you going to be doing today? Okay, well, you're going to be looking at triangles, and then you're going to have to classify them by both their sides and their angles. So, let's say you get something that looks like this, for example. Okay, let's start here with number one, and let's say that I have something that looks like this. It gives me that indicator, and it tells me that this is 5 meters, this is 7 meters, this is 10 meters. Now, so first of all, I'm going to notice that all three sides, okay, that all three sides are different. And since all three sides are different, that's going to tell me that it is a scalene triangle. Because when I classify it by sides, all three sides are different. Now, if you're a teacher watching this video, or you're a student, or a parent watching this video, I want to make it very clear that I'm just using this as an illustration. I realize that this right triangle does not fit in with the Pythagorean theorem. Okay, the idea that a squared plus b squared equals c squared. I realize these numbers do not match to actually fit, but for a 5th grade level video where I am just trying to teach the concepts of scalene, equilateral, isosceles, or classifying the triangle by angles, we're just going to kind of go with this. Okay, but I do understand that the numbers do not work to fit the Pythagorean theorem, which would be for a right triangle. So all three sides are different. That's the scalene triangle. Now we also have to classify it by sides or by angles. I see that I have a right angle because I see my box with the perfect L. Thus, when I classify it by angles, it would also be a right triangle. All right, let's look at a different one. Let's say I have one that looks like this. All right, so I have my triangle, then I have this kind of coming up here, then I have this kind of coming right here. All right, it tells me that this angle right here is 117 degrees, and it tells me that this distance is 7 yards, this distance is 9 yards. Well, first, if I want to do it by sides, I'm going to realize that all three of these, once again, are different. Okay, so I'm going to realize that if I do it by sides, it's going to be scalene. But then if I'm going to do it, classify it by angles, I see that I have an angle here that's greater than 90 degrees. It's 117 degrees. Thus, by definition, this triangle has one angle. It has one obtuse angle. And since it has one obtuse angle, it needs to be classified as an obtuse triangle. And I would need to put scalene and obtuse. All right, we're going to just look at a couple more just to get some different ideas. I'm going to clear a little space here. All right, so we're going to look at one here. We're going to go to example 3. All right, and we're going to have one that kind of looks like this here. We kind of have this here, and we kind of have this here, and we kind of have that there. And we have an indicator here. That indicator tells us that those two sides are the same length. And then I have a 72-degree angle here. I have a 72-degree angle there. And then for it to equal 180, that's 144. So that would be a 36-degree angle there. Okay? So, first of all, I notice that all three angles, the 36, the 72, and the 72, they're all less than 90 degrees, which means they're all acute angles. So that means that this is, when I classify it by angles, it is an acute triangle. However, I also see that I have two congruent sides, okay? Which means that it fits the definition of an isosceles triangle, which means that I also need to put isosceles. And you're going to need to classify it by both angles and sides. So you're going to have to put one for the angles, which is either going to be acute, obtuse, right, and potentially equiangular. And then you're going to have to put one for sides, which will be scalene, equilateral, and isosceles. All right, last one we're going to look at, number 4. All right, and so we have our triangle here, and first of all, we get these indicators that tell us that those sides are all the same. We also get these equidistance here, okay, that tell us that all three angles are the same. Well, the fact that all three sides are the same, that tells us for sure that by sides, it's got to be equilateral, because it's an equilateral triangle that has all three sides the same. If all three angles are the same, that means it's equiangular, because remember, equiangular means all three sides are the same. So I need to include equiangular on my list. However, as we figured out, since all three angles combined are 180 degrees in every triangle, and they're equiangular, they're all the same, and I have 1, 2, 3 angles in a triangle, as we did before, when I do 180 divided by 3, it equals 60, which means all those angles are 60 degrees, which means all of them are acute angles because they're less than 90. So if we ever have an equiangular triangle, it's also an acute triangle because all of the angles are less than 60 degrees. That is classifying triangles by their sides and angles. All right, we'll talk to you later, 5th grade. Bye.